Good morning, dear student. Today we will discuss the Abel's theorem. And Abel's theorem, in this video we propose to show that for a power series with a given radius of convergence and convergent at an endpoints of the interval, the interval of uniform convergence extends up to and includes the endpoints. Furthermore, in such a situation, the sum function f is continuous not only in the open interval minus r to r but also at the endpoint. Here two forms of Abel's theorems are given. The first is regarding the uniform convergence and the second is regarding the continuity. The first form of Abel's theorems is that if a power series summation an x to the power n converges at the end point x is equal to capital R of the interval of convergence, which is open interval minus r to r, then it is uniformly convergent in the closed interval 0 to r. In order to prove the theorem, we proceed to prove that under the hypothesis of the theorem, Cauchy's criteria for uniform convergence is satisfied on the interval 0 to r, and from this it would follow that the summation an x to the power n is uniformly convergent on closed interval 0 r. Let S and P is equal to an plus 1 r to the power n plus 1 plus an plus 2 r to the power n plus 2 up to an plus p r to the power n plus p, where p is equal to 1, 2 up to so on. Then it is easy to verify that a1 plus an plus 1 r to the power n plus 1 is equal to sn1 and an plus 2 into r to the power n plus 2 is equal to sn 2 minus sn 1, and so on. We can write an plus p is equal to an plus p into r to the power n plus p is equal to snp minus snp minus 1. We say this is equation number first. Let epsilon greater than 0 be given. By hypothesis of the theorem, the number series summation an r to the power n is convergent. Therefore, by Cauchy general principle of convergence, there exists a positive integer capital M such that mod of S and P is sticky less than epsilon for all n greater than equal to m and p is greater than equal to 1. We say this is equation number 2. We have also the x upon r whole power n plus p is less than equal to x upon r to the power n plus p minus 1 up to x upon r to the power n plus 1 less than equal to 1 for all x belongs to 0, r. Now using equation first and third, for all n greater than equal to m, we have mod of an plus 1 x to the power n plus 1 up to an plus p x to the power n plus p. This is equal to mod of an plus 1 r to the power n plus 1 into x upon r to the power n plus 1 up to an plus p r to the power n plus p into x upon r whole power n plus p, and this is equal to sn plus 1, the curly bracket is start, x upon r to the power n plus 1 minus x upon r to the power n plus 2 plus up to s n plus p into x upon r to the power n plus p mod value, and this will be less than equal to mod of sn plus 1 x upon r whole power n plus 1 minus x upon r whole power n plus 2 plus mod of sn plus 2 x upon r to the whole power n plus 2 minus x upon r to the power n plus 3 up to sn plus p into x upon r to the whole power n plus p. Now the values of Sn is less than epsilon for all n, so we can put in place of Sn plus 1 Sn plus 2 epsilon. So it becomes this equations, and again this is equal to epsilon into x upon r to the whole power n plus 1, because we can cancel out x upon r to the power n plus 2 with x upon r to the power n plus 2, and similarly here. So we get this value, that is mod of a n plus 1 x to the power n plus 1 up to a n plus p x to the power n plus p is less than equal to epsilon. Thus the mod of this value is less than equal to epsilon for all n greater than equal to m, and p is strictly greater than 1. Therefore the Cauchy's principle for uniform convergence, the power series summation a n x to the power n converges uniformly on closed interval 0 to r. So this is the first form of Abel's theorems, which says that the power series summation a n x to the power n converges at the end point of the given interval of convergence, then it is uniformly convergent in the closed interval 0 to r.